Hi friends, this is the second video of our series. In the previous class, we discussed introduction to measures of central tendencies, arithmetic mean and its properties. Now in this video, we shall be discussing median for both grouped and ungrouped data and its properties. So without wasting time, let us begin with the topic. What is median for a given data set? This is our topic for today's class. Okay, so median for a given set of observations may be defined as the middlemost value when the observations are arranged either in an ascending or descending order of the magnitude. Okay, so for example, if you are having some numbers, say 2, 4, 5, 1, 9, like this. First step is to arrange them in ascending order. We will be arranging them in ascending order. So let me arrange them in ascending order. And when we arrange them in ascending order, what we get is, this is 1, then we have 2, then we have 4, then we have 5, and then we have 9. Okay. The value which lies in the middle, of the observations, or the value which lies exactly in the middle of the observations will be called the median. Okay, so there are two observations to the right of 4 and there are two observations to the left of 4. So what I can say? I can say that 4 is the median. So this is the basic definition of median. But things are not so simple. Depending upon the data type or the grouping of data, we have different formulas for this particular concept which can be approached slowly. So let us move on to different data types. First is for ungrouped data. Let us understand how to find out the median for ungrouped data. Okay, first process, as we discussed earlier, is that arrangement. If it is ungrouped, the list of values will be arranged either in an ascending or descending order. Okay, first step is to arrange them in ascending or descending order of their magnitudes. Second step is to check whether the number of observations are odd or even. Okay, if it is odd, say for example, if n is equal to 5, okay, say in this example, this is the first observation, this is the second observation, this is the third observation, this is the fourth observation, and this is the fifth observation. Okay, so median would be the third observation. Clearly, this third observation is the median. Okay, so this is x1, this is x2, this is x3, this is x4, and this is x5. So x3 will be the median. This will be the median. Okay, third observation is x3 and x3 will be the median. But how to come to this from n? Here our n is 5. The highest position is n is equal to 5. Now to get 3, we will add 1 to 5 and make it even and divide it by 2. So we reach 3. Okay, so that is, if we take n plus 1 by 2, what are we getting? We get, this is 5 plus 1 divided by 2, that is equal to 6 by 2, which is equal to 3. Okay, that is, we are getting the third position. This formula gives the third position. So therefore, median for n is equal to odd number of observations. Okay, if number of observations is odd, then median will be defined as, or median can be obtained using the formula n plus 1 divided by 2th observation, or it is the n plus 1 by 2th value, n plus 1 by 2th observation. Here see, this is the first observation is x1, second observation is x2, third observation is x3, fourth observation is x4, fifth observation is x5. But when we are talking about the third observation is the median, correct? So that is x3. So x3 will be the median. Okay. Now if n is even, now what if n is even? Let us consider a situation. Okay, so we have even number of observations which are arranged in ascending order, and the ascending numbers are like this. This is say x1, this is x2, this is x3, this is x4, this is x5, x6, x7, x8, x9 and x10. Okay, so we have 10 observations. First observation, second observation, third observation, fourth, fifth, sixth, seventh, 8th, 9th and 10th. Now when you think about the middle part, we find that both 5 and 6 lie in the middle. Both 5 and 6 lie in the middle. These are the more centrally located two values. So here in this case, the median should lie somewhere here. The median should lie somewhere here. Okay, the median should lie somewhere here. So this value can be obtained as the arithmetic mean of the 5th and the 6th observation. Okay, so we can get median by taking the x5 plus x6. Okay, x5 plus x6 divided by 2. This is your median. Okay, median is denoted by ME. Okay, so that is x5 plus x6 divided by 2 in this case. Okay, so now what is x5? x5 is obtained by just dividing 10 by 2. What you get is the 5th is 5. When you divide 10 by 2, you get 5 and then you add 1. So you get 6. Okay, so that is when the number of observations is even, then median will be defined as n by 2th observation. N by 2th observation, that is, if the number of observations is 10, if the number of observations is 10, then 10 by 2 will give you the first number. Okay, and then the next number, and then the next one, that is n by 2 plus 1. The next can be obtained by adding 1, right? So that is, this is 5th observation plus the 6th observation divided by 2. What you get is the median. Okay, so this is n by 2th observation plus n by 2 plus 1th observation divided by 2. That is a formula. Okay, next we shall discuss how to find out median for grouped data. How to find out median for grouped data. Okay, now in this case, we need to prepare the less than type cumulative frequency table. Okay, we need to find out the less than type cumulative frequency table. Now this seems theoretical, but then when we solve the examples, these things will be clear to you. Okay, so first listen to the terms of the formula and then we will go on to the problem. Okay, so first we will prepare the less than type cumulative frequency distribution. If we have a grouped frequency distribution, we will convert it into less than type cumulative frequency distribution. Next, we will try to find out or identify the median class. How to identify the median class? The median class will be the class which contains the n by 2th observation. N by 2 is a position. Okay, so n by 2th observation is contained in a class and that class will be considered as the median class. Okay, and then we will find out certain values and put it into this formula. Okay, and put it into this formula. ME is equal to L1 plus n by 2 minus NL divided by NU minus NL into C, where this n by 2 is clear. This total number of observations divided by 2 is n by 2. Okay, now what is L1? L1 is the lower boundary point, or it is the lower class boundary of the median class. It is the lower class boundary of the median class. Here n, you know, it is the total frequency or the total number of observations. Okay, sum of all frequencies. Now NL is the less than type cumulative frequency of the pre-median class. Okay, suppose if we find the median class, okay, median class is say L1 to L2. Median class is L1 to L2. So this is the lower boundary point of the median class and this is the upper boundary point of the median class. Now NL will be the cumulative frequency corresponding to L1, the cumulative frequency corresponding to L1, and NU will be the cumulative frequency corresponding to L2. Okay, that is it. You know what is L1 and L2. L1 is the lower boundary point of the median class, L2 is the upper boundary point of the median class. Okay, now C is the class length which can be obtained by L2 minus L1. L2 minus L1 will be equal to the class length. We assume that all the classes are equally distributed. Okay, now this value nu minus nl is nothing else but frequency of the median class. Frequency of median class. Okay, nu minus nl is nothing else but the frequency of the median class. We can either use this formula or a formula which we have studied in 10th standard CBSE textbooks, where it is like this: m median m is equal to L plus n by 2 minus Cf divided by f into C, where we define n by 2 as the half of the total number of observations. L is the lower boundary point of the median class, Cf is the cumulative frequency of the pre-median class, and f is the frequency of the median class. Okay, and C is the class length of the median class. Okay, so let us understand how to use this formula through an example. Okay, now consider this example. Okay, find the median. Here the marks are given. Here the marks are given to you, and number of students are also given to you. The frequency of the class. This is the class. 0 to 10 has 5 students. 10 to 20 have 8 students. 20 to 30 has 10 students, and likewise. Okay, so we said, what is the first step? First step is to prepare the less than type cumulative frequency. So to find the less than type cumulative frequency, we consider the higher boundary points or the upper boundary points of each class. Okay, so first thing is we will be taking an extra class above all the other classes. So as I have prepared here, so we can see that, so that we can have each and every boundary points from 0 to 50 included. That's it. Okay, so when I take the less than upper boundary point, in this class we have an open-ended frequency, right? Open-ended frequency. So here the upper boundary point is 0, here the upper boundary point is 10, and here we have 20, here it is 30, here it is 40, then here it is 50. Okay, and when you add all the frequencies, sum of all frequencies will be capital N. The total number of observations is N. Okay, total number of observations is N. Is that okay? Hope it is okay. Now, how to find the cumulative frequency? Cumulative frequency. Okay, how many students got less than 0 marks? It is 0. How many students got less than 10 marks? It is 5. How many students got less than 10 marks? It is 5. Okay, 0 or 10 means between 0 and 10, that is 5 students. Same way, how many students got less than 20? It is 8 plus 5. It is 8 plus 5, because those who lie below 10 are also below 20. So how many students got less than 20? It is 8 plus 5. What is 8 plus 5? 8 plus 5 is 13. Okay, and how many students got less than 30? It is 10 plus 8 plus 5, that is 10 plus 13, that is equal to 23. Okay, then we have 6 plus 23, that is 29, and then plus 3, that is 32. So this is how we prepare the cumulative frequency table. Now next, what are we supposed to do? We need to find out the median class. How to find the median class? Median is the n by 2th value. We need to find out n by 2. Okay, what is n by 2 here? That is 32 divided by 2. Okay, 32 divided by 2 is equal to 16. Okay, 16 is the value. So where does 16 lie in the you have to look in the cumulative frequency section. You have to look in the cumulative frequency section. In this section, we find that 16 lies between 13, after 13 and before 23. So it is somewhere here. Okay, so we will be focusing on this region now. Remaining everything will be forgotten. Okay, so once we prepare everything nicely, we will have a table like this. Okay, so the table is ready, and here we are focusing on, we have found out n is equal to 16, and 16 lies between 13 and 23. This is n by 2. N by 2 lies between 13 and 23. Okay, so therefore it lies here. So I am focusing on this region. Okay, I am focusing on these two columns. I am focusing on these two columns, and the median class will be 20 to 30. Median class will be, see, look here, this is 20 and this is 30. So median class will be 20 to 30. Okay. So this is the lower boundary point of the median class, that is L1, this is L2. So the cumulative frequency corresponding to the lower boundary point is NL. Okay, this is NL and this is NU, the cumulative frequency, number of observations below the upper boundary point of the median class. Okay, that is 23. Okay, so I have written down NL is equal to 13, NU is equal to 23. The median class has been identified as 20 to 30. Okay, and class length is 30 minus 20. 30 minus 20 is 30 minus 20, or the length of the median class. This length of the median class will be C. Okay, and then we will use the formula median is equal to ME is equal to L1 plus N by 2 minus NL divided by NU minus NL into C. Okay, and now we shall put all these values into this formula and calculate the value of median. We have L1, we have N by 2, we have NL, we have NU, we have NL and C. Everything on the right hand side is available to us here. We have all written down here. So now we shall just put those values into the formula and use our calculator to find the answer. So the problem will be like this. Okay, so this is the formula. We have the formula here and these are the values N, median class, NL and C and NU. Okay, so now L is equal to 20, L1 is equal to 20. Okay, we have L1, this is L1 and this is L2. Okay, L1 is equal to 20, N by 2 is 16, we have found here. Then what is NL? NL is 13, NL is 13, so we have putting 13. And then what is NU? NU is 23, so 23 minus 13 into C. What is C? C is 10. Okay, so I am putting 10 here instead of this value C. Okay, now just calculate 20 will be as it is plus as it is, then 16 minus 13 will be equal to 3 and then 23 minus 13 will be equal to 10, this 10 as it is. Now this 10 and this 10 will get cancelled, 20 plus 3 will be equal to 23. So you get the value of the median as 23. Okay, so the full problem would be like this. Okay, what we did, first step we prepared the less than type cumulative frequency table. First we prepared the less than type cumulative frequency table, and from that table the first step was we found out N by 2 and N by 2 was found to be 16. Once you find 16, identify or locate a value which is locate those two values between which this 16 lies. Okay, so and then focus on those two rows. Okay, focus on those two rows. This part will be your L1, this is your L1, this is your L2 and this is your NL and this is your NU. Okay, so everything is available to you, and then 20 minus 30 or 30 minus 20 will give you the class length. Now punch these values into the formula, put these values and then calculate and you get the value of the median. Hope that formula and the problem is clear to you and you can now solve any kind of problem. Now in case if you are not given exclusive class intervals, you can either convert them to exclusive class intervals and then solve the problems, or else it is not necessary to convert all of them except the median class. We need to convert the median class to exclusive class. We need to convert the median class to exclusive class in case if it is not exclusive. Okay, exclusive means we need to convert it into continuous form. Okay, and then we will get L1 and L2. Okay, next, now we shall discuss properties of median. Median is affected by change of origin and scale. Suppose two variables say x and y are given to you, and y we know everything about x. We know the median of x. X is a set of all data and x has been converted to y using some formula, and the formula is given as y is equal to a plus bx. That is, we have changed the scale using b and changed the origin using a. Okay, so what will be the median? What will be the median of y? What will be the median of the new set of observations y? y1, y2, y3, y4 like that. Okay, each x has been operated and converted to y using these kind of expressions. Okay, so then median of y, okay, y median, okay, median of y will be equal to, a plus b into median of x. It is the same relation. You just, if you have the median of x, just put it into the same expression and you get the median of y. This is a very important problem. Problems on properties are asked like this, okay, from this topic, and the remaining properties are theoretical where MCQs can be asked. Okay, here for a given set of observations, the sum of absolute deviations, is minimum when the deviations are taken from the median. Okay, sum of absolute deviations. What do we mean by sum of absolute deviations? Suppose if we have a set of data, say xi, so each observation is subtracted, or from each observation, if we subtract the median, and take the absolute values and then their sum, and suppose instead if we are taking the sum of, okay, the deviations taken from any other value, okay, sum of deviations taken from any other value, the absolute values of the deviations taken from some other value, then this value will be the minimum value out of all these values. Okay, that is what we mean. If A is chosen as the median, then we get this value, sum of absolute deviations, sum of positive deviations from the median will be minimum. Okay, will be minimum. That is sigma modulus of xi minus a is minimum if a is the median. Okay, next, median is the best measure for open-ended class distributions. Median will be considered as the best measure for open-ended class distribution. Best measure for open-ended class frequency distribution. It's a very important property, generally asked as MCQs. You already have only MCQs in your paper for CA foundation course. Okay, now if all observations are constant, if all the values in a given data set are equal, that is constant, then the median is also the same observation. Okay, it is also the same constant. Okay, if all observations are same, if all observations are constant means the observations are not changing. If all observations are identical, then the median is also the same observation. Okay, so these are the properties of median. Now we shall solve some problems related to median. We shall try to find out median, and different kinds of manipulative problems will be solved so that we can understand the theory and the content properly. Okay, first problem, concept practice problem 1. Let us consider this example. Here we need to find the median of the following distribution. Okay, here class interval is given to you and the frequency is also given to you. Class interval is given to you and frequency is also given to you. Now, as we said before, we need to convert them to the less than type cumulative frequency. So I have written down all the question part. This is the question part, and we have converted it to less than type cumulative frequency distribution. Less than type CF. Okay, we are trying to prepare the less than type cumulative frequency. So we will consider the upper boundary points here. Okay, as we discussed in the previous problem, that in case if they are not exclusive, we will consider the boundary points or the upper boundary points as extended one. Okay, we convert each one of them to the exclusive part, and then what we get is 349.50, 369.50, and this is 389.50, and then this is 409.50, and so on. Okay, what we get here is this is 429 becomes 429.50, 449 becomes 449.50, 469 becomes 469.50, and 489 also becomes 489.50. Okay, they are extended on either sides. We know that how to make inclusive classes to exclusive class. So that is the first step. We convert or take the upper boundary points. This is the upper boundary points. Upper boundary points. Okay, and then this is the cumulative frequency. Cumulative frequency. This is the cumulative frequency. How to take the cumulative frequency? We all know this. How to find the cumulative frequency distribution. Okay, so let us try to find. So this is 0. I'll put 0 here, and then 23 plus 0. 23 plus 0 will be 23, and then plus 38 will be 61, plus 58 will give you 119, plus 82 will give you 201, and then plus 65 will give you 266, plus 31 will give you 297, plus 11 will be equal to 308. Okay, and this value should be equal to the total number of observations, that is n. Okay, so once we have n here, we will try to find out n by 2, and n by 2 is this. Okay, n by 2 is 308 divided by 2. This is 308, and 308 divided by 2 is 154. Now 154, we try to find out or locate 154 in the cumulative frequency part. We try to locate 154 lies between 119 and 201. It lies somewhere here. It lies here. So the median class is 409.50 to 429.50. So this we are going to focus on. We are going to focus on this region. We are going to focus on this region. Okay, it is very clear. We are going to focus on this region, and this is where the median lies. This median lies somewhere between this thing. It is median is the 154th observation. 154th observation lies between these two values, between these 119 and 201. So therefore, we consider the corresponding boundaries, that is 409.50 and 429.50. So this is your L1, this is your L2. Okay, L1 is 409.50 and L2 is 429.50, and this is NL lower boundary point and NU for the upper boundary point. Okay, fill out all the values into the formula. We identified the median class. This is L1, this is L2. The class length is the difference. You get 20, and put it into the formula. We'll put it into this formula. We'll put it into this formula. Once we put all these values into the formula, what we get is the median. Calculation, I think I need not explain. Okay, this is the n by 2. N by 2 is 154. NL is 119. The same thing here. And NU was 201. Okay, and class length is 20. L1 is 409.50. Calculation will give you 418.04. This is the value of the median for the given question. Okay. Next problem is the concept practice problem 2. Here in this case, what is available to us? Find the missing frequency from the following data, given that the median mark is 23. The table is given where a frequency is missing, a value is missing. Okay, so here suppose it is f is the missing value. We know that the median is 23. So we have median as 23. So the median class, where does the median lie? Median is 23. So just take 23 and check in which class does 23 lie. Median is one of the observations, right? So observations lie in the classes. So median lies here. This is the median class. Identified the median class. And what kind of classes are they? They are exclusive classes. So we need not convert them further. So this is our L1 and this is our L2. Okay. Now we need to convert this thing into cumulative frequency distribution. Okay. So the upper boundary points will be considered. I consider an extra class. Okay, with the lower boundary point of the first class. That is, this is the extra class. Okay. Then we start with the upper boundary points. This is 10, then 20, then 30, then 40, then 50. Okay, that is what I have written here. And then I keep on adding one by one. Okay, the first one is 5. For 5 observations below 10, 8 plus 5 observations below 20, 8 plus 5 is 13, okay, this is 8 plus 5, okay. Then again when you add f, so it becomes 13 plus f, then you add 6, you get 19 plus f, and then you add 3, you get 22 plus f. This is the total number of observations. When you add all these values, you get 22 plus f. This is the n. Okay, so n is 22 plus f. NL is equal to 13. Why NL is equal to 13? Why NL is equal to 13? We know that this is the median class, 20 to 30 is the median class. So we are going to focus on this region. We are going to focus on this region. 20 to 30 is the median class. This is the median class. Okay. So this is your, L1, this is L2, and let me clear this off. We are going to focus on this region. Okay, this 23 lies here, 23 lies here. Okay, the median, when median is given, you need to look into the less than type. If median is not given, we will find n by 2 and we will check where does n by 2 lie. Okay, that is how it is done. Now 20 to 30, this is your L1, this is your L2, this is your NL, and this is your NU. Okay, now what is the class length? Class length is 20 to 30 is 10. Okay, so class length is also ready. Now we shall put all these values into the formula. And what is the formula? We know that median is equal to L1 plus n by 2 minus NL divided by NU minus NL into C. Okay, when you put the values, what you get? When we put the values, we get L1. What is L1? L1 is 20. So we get 20 plus n by 2. What is n by 2? N by 2 is 22 plus f divided by 2. Okay, this is 22 plus f. N is 22 plus f divided by 2. I'll take this in brackets. Plus NL. What is NL? NL is 13. NL is 13. So it is plus 13 whole divided by NU minus NL. Where is NU? NU is 13 plus F minus 13. So it is 13 plus F minus 13. Okay, into C. What is C? C is 10. Okay, 10. So when I calculate this thing or simplify this, so it will look like this. Okay, neatly. When I am writing, it may not be clear to you. So everything is written clearly here. So, and also one more thing, the value of median is also given to you as 23. So we are putting the value of the median also here. So we have 23 equal to this value. Okay, so we get this, and this is neatly written down here. Okay, so 23 equal to 20 plus 22 plus f by 2 minus 13 whole divided by 13 plus f minus 13. This 13 and this 13 can be cancelled. Okay, into 10. Now when you simplify, this 13 into 2 is 26. Okay, and the 2 will come in the denominator, and that 2 will get cancelled with 10 and we'll get 5 here. Okay, so 3 will be equal to, why, how 3? This is 23 minus 20. This 20 will go there and it becomes 3 here. So you have this result, and then simplifying this 3f, f is multiplied on that side, and 22 minus 26 will give you 22 minus 26 into 5 will give you 20. Okay, this is 4 5s are 20, and f into 5 is 5f. Okay, so we get this, and then 5f minus 3f is 2f equal to 20, therefore f will be equal to 10. So we have found out the missing frequency, f is equal to 10, so we can write 10 here. Okay, so this is how to solve this problem. Now we have discussed properties of median. So one question based on the property of change in scale and origin. Okay. Now here we have the relation. Between x and y as x minus 5y equal to 10. So we will write that relation here. It is x minus 5y equal to 10, and we already have the median of x. Median of x is given to you as 16. We need to find out median of y. Median of y is to be found out. Now let us make this equation or convert this equation so that it looks y equal to something form. So I'll take the 5y on that side. So I get 5y equal to x minus 10. Okay, I am taking this 10 that side, and this 5y will be taken this side, and then return it in the reverse order. Okay, so 5y equal to x minus 10. So y becomes equal to x by 5 minus 10 by 5. Okay, x by 5 minus 10 by 5, or this is the expression. So we can just replace x. We can write this as x minus 10 divided by 5 equal to y. Okay, we can write this as median of y equal to median of x. Okay, from here we are going like this: median of x minus 10. Instead of x we take median of x, and instead of y we take median of y. That is how the formula will be manipulated. Divided by 5. Okay, so when you put the values, what is median of x? Median of x is given to be 16. Median of x is 16. So we have 16 here minus 10 divided by 5. Okay, so what is this value? This value will be equal to 16 minus 10 is 6 by 5. So 6 by 5 will be equal to 1 point something. Okay, what is 6 by 5? Let me write down here and check. This is 6 divided by 5 equal to 1.2. Okay, so the answer is 1.2. 1.2 is the median of y. Okay, so these are the different types of problems which relate to median. Now we shall discuss some more theory part, that is some merits and demerits of median. Where median can be used, where median cannot be used. These topics are very important for MCQs. Okay, direct questions can be asked from these topics. So let us discuss merits of median. Okay, let us discuss merits of median. So these are the merits of median. Median is very easy to understand and simple to calculate. In case of ungrouped data, it is very simple. We just have to arrange them and find the middle value, and the median is ready. Okay, very simple. Now median is useful in case of open-ended classes. See, what is open-ended classes? See, look at this example. In this example, we know that. What do we observe? We observe that. See, look, this class, we don't have the lower boundary point. Less than 10 means how much? Not known to you. And more than 40 and above means more than 40 means it is not bounded below and it is not bounded above also. Okay, so this is both side open. In some questions we may have, in some situations we may have left side unbounded and right side bounded, or either ways. Okay, in this example we have taken both unbounded. Okay, so in case of open-ended series, the median will be useful. Okay, median will be useful to find out the measure of central tendency in case of open-ended series. Okay, now median is the most suitable average for qualitative data. Median is suitable for arithmetic mean was not suitable for qualitative data. It was only suitable for quantitative data. In this case, the median will be suitable for, it is most suitable average for qualitative data is median. That is when ranks are given. Okay, qualitative data can be ranked, and median is most suitable average for qualitative data. Remember this point, very important. Okay, now median can be determined graphically, which using the help of cumulative frequency curve or ogives. Median can be determined graphically with the help of cumulative frequency curve. We know that, okay, this blue line is the less than type cumulative frequency curve, and the red one is the more than type cumulative frequency curve. Now the point of intersection of those two curves, okay, if you draw a perpendicular from that point, and that perpendicular, the foot of perpendicular, or the point where it intersects, this point will be the median. This point will be called the median. Okay. So, median can be determined graphically with the help of ogive. Okay, median from ogive. Okay. Next, median is not affected by extreme values. Median is not affected by extreme values. Look at the example. See, in this case, we have 4 values. This is 1, 3, 5, 7 and 9. These are the values. Now, the median is 5. Median is 5. Now, if instead of 9, I take 14. Instead of 9, if I take 14, what happens? The extreme value increased to some, but we are not concerned about the value. We are just concerned about the position of the observations. We see there are 1, 2, 3, 4, 5 observations, and the third one lies in the middle. So, this is the median. Same way, we have 1, 2, 3, 4, 5 observations, and the third one lies in the middle. So, third one is the median. So, it does not depend upon extreme values. It is not affected by extreme values. Okay. So, that is what we mean by median is not affected by extreme values. Okay. Now, finally, we shall discuss some limitations of the median. Okay. Median requires, median requires rearrangement of data. Median requires rearrangement of data. Median requires rearrangement of data. We need to arrange first of all, and if you are not wanting to arrange, then you cannot find the median. Okay. Then median is not rigidly defined. It is dependent only on the position, not on the value of the observations. And its value cannot be computed actually, but be located. Okay, because it is positional average. It is just the position. Any observation which occupies that position will become the median. It is not dependent on the value of the observation, but it is dependent on the position of the observation. Okay, after arrangement. Now, median is not based on all the items of the series, but only on the position. Again, it is the same thing. It is not dependent on the value. Median is not based on all items of the series. It is not based on all items of the series. Median is not capable of mathematical treatment or algebraic treatment, not capable of algebraic treatment. Median is affected by sampling fluctuations than the value of mean. Okay. So, if the sample changes, median may not change. So, therefore, the output, the analysis may be affected because the median is not changing according to the sample. Okay. So, that is again an issue. You cannot get the correct median or correct measure of central tendency in case if you choose median as one of them. So, median is affected by more sampling, median is affected more by sampling fluctuations than the value of mean. Mean is not affected by sampling fluctuations. We have studied these things. Okay. So, this is what we have in this class. Next, we shall discuss partition values or fractiles. Okay, where we shall be taking the median again as a partition value, quartiles, deciles, percentiles, and how to find those values will be discussed in the next class. Okay, so goodbye.